So we're working with the income and education data. What we have here is the calculation of the slope and the intercept. This replicates what is in SPSS. So if we were to run this in SPSS, here are our values. So the slope function is 2922, and the y-intercept is minus 1919. So this is a big data set. Roughly about, I can see here, there's roughly 28,945 records. Okay, so what we're going to do now is we're going to look at some diagnostics. So I'm just going to insert an extra row here, and we're going to calculate the predicted value. And that is equal to the y-intercept plus the slope function times by the years of schooling. And I will calculate that for everybody. So what I'm looking at is I'm looking to see how the how well my model predicts. Because what I'm saying with my equation is every year of schooling adds basically $2,900 to a person's income. So I'm predicting that if you have more years of schooling you have, the higher your income. It seems to fit. Now, what I want to do is I want to look at diagnostics. So I want to see, because one of the assumptions I have, and you'll see in the slides for the lecture, is that my data has to be normally distributed. Okay, so one way to look at that in terms of the regression model is to look at the difference between my predicted and my residual. So now I have to calculate my residual, which is equal to the actual value of earnings to the actual earnings themselves. Okay, so let's see what this looks like. So equal to the actual earning minus the predicted earning. And that's referred to as my residual. Now my residuals here look really funny. The person's earnings were basically $25, and I'm predicting a minus 49,000, and on up. Now as I get more towards the middle, things should start looking a lot better. So 31,000, 50,000. Now once again, this isn't the best predictor. Okay, so let's put in a plot. So I'm going to insert a scatter plot, and it's going to be, and here it is. Now my residuals, as you can see here, for my low values, my residuals are much smaller down here, and I can see here it fans out up here. I don't have very many residuals that are on the negative side of the value, so I'm not very often under predicting the income. But I can look over here, my residuals are fairly high. So I have 1.2 million outlier here. So that's a positive one. I grossly underestimated what the income should be because the residual is so high. So the person made roughly predicted to make $50,000, and my residual is 1.2 million based on their years of schooling. So I have what's referred to as a problem here in terms of my data. And what that means is my income data is not normally distributed. And the best way to see that is I can look at it in SPSS. So if I go to SPSS, Analyze Descriptives, Explore, and I pick Earnings, it's going to clearly show me that the data is not normally distributed. And if I look at my stem and leaf plot, here's what it looks like. So there's a high skew to my data. My data is very positively skewed. So I have a few people, not very many, but what happens is there's a good chunk of them that are making well over $1 million. So my income data is not normally distributed. Now, in what I need to do is I need to transform my data. So if I look at it, this is the residuals. This is from SPSS. I can see those outliers here. And here's my stem and my box and whisker plot showing the outliers here. What I need to do is I need to transform the data by bringing in the outliers or the extreme values that create that positive skew. And with income data, the easiest way to do that is to take the log of the data. And I'm showing here, for those who have access to SPSS, that's what it looks like. So what I'm going to do is I'm going to log the data. I'll do it in SPSS first. So I'm going to transform compute. And I'm going to create earnings log. And it is equal to the log 10 of earnings. Then I go OK. So I'm creating a log of the data. I look at my data. I have a new variable, earnings log. Now, if I analyze descriptives Explorer, and I look at the log data, I can see that my data now is from the stem and leaf plot is looking fairly normally distributed. And I'll also see that for my box and whisker plot. It's normally distributed. So logging the data made my dependent measure normal, which is what I want to do. And now I would run my regression, not using earnings, but using the log of earnings. And my plots, I can look at my predicted value as the x variable and my residual. And here I have the standardized residual. And continue. Here is my new model. My R squared is now 0.063, and my correlation is 0.25. And this is the model that this is what I would use in terms of explaining the relationship between education and years of schooling. My scatter plot here of the my predicted predicted income or earnings, and my standardized residuals, z-scores of the residuals. And I can see now that I have a good fanning out of residuals on the negative side, where I over-predicted, and I have a good sampling, a distribution on the positive side, where I under-predicted. And that's what I want to see. It's critically important in simple regression that my data be, my dependent variable be normally distributed. I'm going to close off. I ran through the example in SPSS and Excel. Moving forward, if you wanted to, you can calculate the log in SPSS and rerun the regression model with this data. For the assignments for the course, I would use a much smaller database for you to do this work.